Okay, we're finally ready to start talking about EOS. I wanted to go over the general ideas of what EOS brings to the table, what it's doing new, things like that. And I figured we could just look at the white paper and kind of go through it step by step, and I would just point out very high level details associated with it. The only reason I wanted to look at the white paper is I wanted to make sure I wasn't forgetting anything, because it's very hard when you're recording. Anyone who's ever tried to record video, I'm sure it feels the same way. After you record it, you're like, oh shoot, I should have said this or whatever. And since I'm not really editing these, I'm doing them all in one take. It's hard to try and squeeze in last minute things that I forgot to talk about. So what we'll do is we'll just kind of go through the EOS white paper, talk a little bit about it, and I'm hoping in the next video we'll go through the EOS white paper again, having kind of explained all of the high level concepts, and I can kind of compare it to what Ethereum does in the same kind of way. So in this first section of the white paper, they kind of outline the requirements, essentially, like the engineering requirements that they're trying to achieve with this architecture and with the blockchain at large. The first one is obviously scalability. One of the big problems with Ethereum is it's not scaling very well, so obviously that's something EOS is trying to fix. The other one is free usage. So if you've ever used the Ethereum platform, you know you have to go buy Ethereum somewhere at an exchange using your fiat currency, and that's in order to pay gas costs and all this other stuff. So one thing they're trying to solve is free usage, and as we talked about previously, Dan's kind of done this with Steemit. It's the same kind of idea. With Steemit, you were able to just join the platform. You didn't need to know anything about cryptocurrency. So they're trying to kind of apply that same idea to EOS here. And in fact, I don't know, I almost feel kind of like EOS is almost like Steemit with smart contracts in a sense. So most of the things that apply to Steemit are also going to apply as well to EOS. This next one is easy upgrades and bug recovery. So if you're familiar with cryptocurrency at all, you've seen kind of a lot of the bugs that have really hurt people in Ethereum, like the DAO hack is one, and the parity multi-sig hack was another one. Well, that one wasn't even a hack. That was just somebody being an idiot. So they wanted to add upgradability from the ground up with the EOS platform, and I think they talk more about that later, as far as how that goes. Because one question you often see in the Telegram is someone comes in and goes, well, what's to stop somebody from uploading a smart contract that does one thing, and then 2 days later they upload a different smart contract that steals everybody's everyone's EOS. They discuss that later in the white paper as well. Low latency kind of goes hand in hand a little bit with the scalability thing. You want to be able to handle lots of transactions and handle them quickly. Sequential performance, it's kind of what we talked about when I went over the Steemit architecture a little bit. They want to be able to handle sequential transactions as quickly as possible, and then also parallel transactions as well. The sequential ones are obviously, like I said, are in cases where you need to take money from one person before you can do a second transaction that's dependent on that first transaction, things like that. Okay, the next thing is the consensus algorithm. If you're familiar with blockchains, Bitcoin is proof of work. Ethereum is also proof of work, but they're moving to pure proof of stake. Well, they're going to have a hybrid in between where they do proof of work and then go to proof of stake. Eventually, they're trending to full proof of stake. EOS uses delegated proof of stake, which means you're kind of voting for the people who are going to be staking and collecting the blocks and transaction fees and things like that. That's what the delegation means. You're delegating by voting. You're using your tokens, saying, I want these 21 block producers, these quote-unquote miners, essentially. You also see here the BFT. So it's BFT-DPoS. So Steemit is pure DPoS, and what EOS did is, in this iteration of the blockchain, they found a novel use for asynchronous BFT, Byzantine fault tolerance. Sorry, I should have said that earlier. Asynchronous BFT in order to speed up finality of the blocks. So that's yet another, like thing that sets EOS apart and makes it much quicker. Again, we'll talk about this later. Well, in fact, I think it looks like it's comes up here, right here, transaction confirmation. So if you've ever used the EOS or the Ethereum blockchain, you've done a transaction and then you've sat and you've waited for the blocks, like X amount of blocks need to get confirmed right before like the exchange credits your account with Ethereum tokens. That's because it's like mathematically proven, right, that in Ethereum, once you get a certain amount of blocks, there's like 99.99999% probability that your transaction is actually on the blockchain and some crazy fork isn't going to happen after that, which is what we typically call finality. We're saying like, okay, the block is final, it's immutable, it's going to be on the blockchain forever, right? What they've done with this asynchronous Byzantine fault tolerance is they've made the finality much, much quicker. Here it says irreversible within 1 second, which is way faster than anything else that's out there right now. I do know Definity is working on what they're calling near instant finality. So it's an obvious like problem in blockchain right now that everyone's trying to solve, and this is how EOS decided to solve it. So the next one is transaction as proof of stake, and what this does is like when we talked about the Bitcoin blockchain, and I said, okay, every block references a hash of the previous block, and that's how it knows how to get back. Well, what they've done with this transaction as proof of stake thing is every transaction also points back to the previous block as well. And that's mostly for the inter-blockchain communication stuff, which we'll see later. This is just proof that you're actually on a specific fork of the EOS blockchain. Okay, the next major part of the EOS white paper is accounts. Anyone who's used the Ethereum blockchain, I guess this is also going to be the video where I compare between Ethereum and EOS. I didn't think I was going to do this, but I wanted to go through EOS specifically, but it's too hard to just like talk only about EOS without talking about Ethereum, because I think a lot of the things that are in EOS, the reason they're in EOS are to fix the problems with Ethereum. So scratch the next video. This one's going to be the Ethereum versus EOS video as well. Anyway, as I was saying, if you've ever used Ethereum, you have these big old long addresses, and that's essentially your public key, and that's how everyone knows if they're going to send you Ethereum, they know where to send it. If you're going to send tokens, they know where to send it. What EOS has done is they've kind of abstracted that away to make it more user-friendly, and you'll see this come up again and again in the white paper. Is they're constantly striving for user experience, which is what I really like about the platform. So here you can have an actual account name, and then that's tied to your public key and your private key as well, but it allows you to, like, when you're interfacing with the blockchain, just use your account name for things like that. Actions and handlers is, I don't want to get too far into the details because we'll talk about actions and handlers when we actually start writing code, so let's kind of skip that section. Role-based permission management, because they're doing this account-based thing, they're also adding like multi-sig style permissions to an account, so you can have like a social media account permission and different things like this. What it also allows you to do, and I think this is kind of a big breakthrough, I think Steemit has the same thing actually, but it allows you to choose another account as your safety account. That way, if you get hacked, like if you get hacked on Ethereum and someone figures out how to get your private key associated with your public key, you're basically screwed. Like you're not getting that money back, and there's really nothing you can do about it, short of like trying to transfer your Ether to another address before the hacker gets a hold of the funds. With this, you can kind of actually lock your account for some certain period of time, and then this backup account that you've created for safety reasons can actually verify, yeah, you got hacked, yeah, you're the correct person, and we're not going to give this other private key access to your account, which I think is a really big breakthrough as far as like user experience goes. I think it's somewhere down here where they actually talk about this. Oh, maybe not. This is kind of like a newer version of the white paper than the one I read initially when I started developing on EOS, but it's definitely in there that you can, save people essentially if they get hacked, which is really good. Let's see, what else do we have here? Oh, here it is, recovery from stolen keys. So, like I said here, 30 days. It looks like. I think you can set that to whatever value, but someone can actually come in and save your account if you get hacked. And I often when I'm talking to like people who have no idea about blockchains, and people are scared to invest in Bitcoin and cryptocurrencies because they hear of all these stories about people getting hacked or like sending cryptocurrency to the wrong address, things like this. I think EOS is doing a good job of like trying to protect regular users who don't know anything, and I think that's because of Steemit. Like the whole idea of Steemit was social media on the blockchain, right? And a lot of social media creators are not necessarily cryptocurrency advocates, and they don't know anything about cryptocurrency. So I think Dan learned a lot of lessons as far as like what confuses regular users, and let's try and fix that in the next iteration of the blockchain. Let's see, what else do we have here? Deterministic parallel execution of applications. This is kind of similar to what I was talking about previously about how like they've separated like what should be parallelized and what should be sequential in execution. So they talk about that here in the blockchain, or sorry, in the white paper. Minimizing communication latency. So this little diagram here, I think when I first read this, I was like very confused by it. Like, what do they mean? What's going on here? It's actually kind of, I think, been pushed out. Like they're no longer working on this for the first release of the blockchain. So I don't know, maybe you might be watching this video in a year from now or whatever, but let me spell out now that I'm recording these videos before the actual mainnet gets launched. And as far as the mainnet goes now, they're not doing parallel execution like directly in the chain. I think they say that somewhere here in the right here. EOS will run single threaded, but they've coded it in such a way that this parallel execution can actually happen later on. They did this in order. They worked on the IBC, the inter-blockchain communication, as a scalability solution before they worked on this parallelization. So the inter-blockchain communication stuff should be in the mainnet launch, but this stuff won't actually be. But again, this goes back to what I was saying about parallel and sequential execution. You can read through this section if you're really interested in it. This is just more details outlining, like, this is how we're achieving this separation of sequential and parallelization, things like that. Subjective best effort scheduling is essentially the block producers kind of get to pick. So in Ethereum, when you run out of gas, like there are gas limits, right? So you can't do infinite loops, things like that. With this, they're letting the block producers decide like what is an infinite loop, like how long are we going to allow this transaction to actually happen. Here's the context-free action stuff I was talking about previously. What I was saying, I wasn't that familiar with it. One thing here is like signature verification. They're saying that's a context-free action. Essentially, it's an action that doesn't depend on blockchain state and only on the actual transaction data itself, which again allows for parallel execution. The EOS blockchain still needs a way of like fighting against spam, right? Like they can't just let anyone create a transaction on the blockchain at any time, because people are going to be nefarious and they're going to just like spam the network. Ethereum handles this with gas, right? I'm sure most people are well aware of this. What EOS does is it uses a staking mechanism. So you stake your tokens, and that gives you a certain allocation of bandwidth, computation, and RAM. There's a lot of details that go into this, and I think they're still like working kinks out for the actual blockchain release. But again, we'll kind of talk about this when we actually start writing code. This makes a lot more sense when you're talking about code, especially the RAM, the RAM section of this, because we'll be putting things in the blockchain RAM and taking things out, and we can talk about what's happening as far as like token staking, things like that. The bandwidth and the CPU are actually, it says somewhere here, like they're transient, right? So you don't actually necessarily need to stake all the time when you're using active components of this, but you do need to do a 3-day stake for like your actions that actually use the CPU get logged on the blockchain, so they kind of need to take for that as well. It's a little bit more complex than Ethereum's solution, which makes it a little bit more nuanced, but I also think that makes it more efficient and more effective, to be honest. Oh, this is actually this objective and subjective measures I was saying, talking about block producers can kind of pick what can and can't be used. What is this? Oh, the subjective best effort scheduling just means the block producers actually get to pick how they're going to schedule transactions. Sorry, I was wrong about that. This is the one saying they get to decide, quote unquote, what an infinite loop is. One of the kind of most interesting aspects of EOS is it allows for various different payment models. So one of the, poor user experience qualities of Ethereum is the fact that the sender is always paying for transactions, which makes it hard for people who don't know anything about cryptocurrency to actually use the blockchain. In the EOS model, you can kind of set it up however you want. Like the smart contract can pay for it, the sender can pay for it, the receiver can pay for it. Like it's all open and anything can happen. I suspect most people are going to use the receiver pays or the DApp pays kind of method, just because most of us developing on EOS are I would say, like, user experience advocates, and we think that's the way of doing things in the future. But you never know. What they've done is they've allowed it to say, like, okay, the community can decide. We're not going to place that burden on users all the time, and we'll let the developers figure it out however they want to do it. Another thing here is you can delegate your EOS stake. So, like, if I'm not using my bandwidth, I can delegate it to somebody else who's building a DApp that I find interesting or something like that. I think this capability is actually in Steemit as well. It's a similar concept between the two blockchains. Oh, let's see, what else do we have here? State storage costs. Like I said, there's RAM. You're going to pay for RAM when you're using it, and you'll get your tokens back when you're not using it. Block rewards, these are going to the block producers. There's a worker proposal system where essentially the community will fund different projects they find interesting using the block rewards. Here's another kind of interesting aspect of EOS is the governance. So often when you see both Bitcoin and Ethereum deciding to fork, there's like these massive arguments in the community and people are fighting on GitHub and all this other stuff. So knowing that Dan saw that, he also saw the same arguments happening on BitShares and on Steemit after that. They decided with EOS to bake governance into the blockchain, whereby you have this constitution that gets signed on every block. So everyone's essentially agreeing to the terms of service of the blockchain every time the block comes up. But there are actual ways of changing the constitution, changing the governance, and all that other stuff. They kind of go through all of that, how to upgrade the protocol. All these voting steps have to happen. So it's not to be taken lightly, but there's an actual process in place to actually do that. And I think one of the most interesting aspects of EOS is to see how does this actually work. If something bad were to happen or does happen on the chain, it'll be interesting to see how upgrading this protocol and this constitution actually works. Another thing you can do is freezing accounts, which I don't know, you kind of get into this argument of centralization, decentralization, which I think that's most people's argument against EOS is it's centralized, more centralized than other places as the argument goes. And I'm going to stay out of that. I don't want to, this should be a technical thing. I'm teaching you how to write code. I don't think political discussions of centralization versus decentralization are for this. But I could write a blog post about that later if you want my opinion, and we can talk about that offline or something. But the ability to freeze accounts. So if something really, really, really bad is happening, for example the DAO hack, the block producers can't have the ability to actually freeze accounts. So if the DAO hack happened on EOS, you could block that person's account without having to do a hard fork. Here's another one. You can change contract code, smart contract code, doing voting and things like that. Again, it's how good do you feel about letting 15 or 21 block producers decide your fate? That's an argument for another day. Let's see. But what I will say about this is I like the fact that they're at least thinking about this. Like, they're well aware, like, bugs happen, people write bad code, people do nefarious things, hacks happen. Like, whether or not this is the right way of solving the problem, I commend them for actually, like, thinking through this and saying, like, okay, we need some way of doing it. Whether this way is the best or not, we'll find out. Okay, so here's when they start actually talking about code, like how do you write code on EOS. A lot of questions come up on Telegram about this. The code actually gets compiled to WebAssembly. Currently, from what I've heard, is the C++ has the smallest WebAssembly binary, and therefore it's like the easiest way to write smart contract code, because uploading a massive smart contract that takes up a lot of data is either, I don't know if they've set limits or not, like this might be impossible, or it might be super, super costly to do that. So if you were to write a smart contract in, say, JavaScript, and it gets compiled to WebAssembly, and that WebAssembly is like massive, 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 then you probably aren't going to be able to upload it to the blockchain. Currently, again, this may change after I record this video, but currently C++ has the smallest WASM binaries, so that's why they're writing the code in that, and why they're able to upload those to the blockchain. They use ABI similar to what Ethereum does, so you have like a way to convert the binary to JSON. Similar here, we have databases. We'll see this when we start writing code. There's a multi-index database for EOS smart contracts. This allows you to interface with the RAM and store user data and delete user data, update user data, things like that. Well, I guess technically it doesn't have to be user data. It could be data of any kind. Again, this is a shout out, like I was saying. The Steam at Blockchain white paper spells this out explicitly, separating authentication from application logic. So you can see there are definite learnings from Steemit, and they're being applied to EOS. So same thing goes here. Okay, and then finally the last section here is the inter-blockchain communication. Like I said, up here they kind of elected to put off this parallel execution stuff up here in lieu of implementing the inter-blockchain communications. And what this is kind of doing what the plasma chain stuff for Ethereum is doing, where this should allow anyone to spin up their own chain and verify transactions on the main EOS chain, and the main EOS chain can also verify transactions on these side chains that are happening. So that's a way of handling scalability problems, so that the same 21 block producers aren't necessarily having to handle all sorts of other state data. So like if you wanted to do an EOS side chain for an Airbnb application or something like this, the main EOS chain doesn't need to know that. It doesn't need to be bogged down with all those transactions. So this just kind of steps through all the cryptography that goes into making something like this happen. This will be kind of interesting to see, like, if it makes it into the mainnet release, like how developers are going to use this. I'm very interested to see how this works out. I think that's pretty much everything. Yeah. I mean, these are just like little additions to the IBC stuff, segregated witness, proof of completeness, all that stuff. You're free to read these if you're interested. So I guess, like I said, since I smushed the comparison between Ethereum and diving into the EOS white paper, we might actually just start digging into smart contracts after this, getting everything set up, maybe looking at EOS GitHub code to see best practices when developing smart contracts, things like that. Unless I think of something after the video, like I said, this always happens when you record videos. If that is the case, then I'll jump on, do another video, like, oh, this is another interesting comparison between the two chains, or anything like that. See you in the next video when we'll start getting on the command line and getting everything running.